Okay, hello everyone, welcome to the OneClass channel. My name is Andrew and I'm currently doing stat and math at the University of Toronto. Today we'll be going over some commonly asked math questions at both the high school and college levels. If you need some homework help or tutoring, please check out the link in the description below. Alright, so let's start our session for today. Okay, so our first question today is asking us what is integration of 1 over x. So what is integration of 1 over x? Okay, so according to the definition, ln x is equal to integral lower limit as 1, upper limit as x, 1 over t dt for x is greater than 0. So the antiderivative, or say the integral, thus the integral of 1 over x is ln x plus c, where c is the constant, okay, and integral 1 over x dx is equal to ln x plus c. Okay, yeah, so that's what we have for this question. Okay, let's leave a comment. Solution is correct. There we go. Okay. For our second question today, we're asked to find the slope of the tangent line. Find the slope of the tangent line to the curve y is equal to x over 1 minus x as a point 1 over 2, 1. And we need to find the equation of the tangent line. Okay. So, oops. So given the curve y is equal to x, 1 over 1 minus x, and a point 1 over 2, 1, the slope of the given curve dy dx should be equal to d dx x over 1 minus x. And from the quotient rule, over here, apply we will have derivative of x times 1 minus x minus derivative of 1 minus x times x over 1 minus x squared. Okay, and derivative of x is just 1, so that becomes to 1 times 1 minus x minus derivative of 1 minus x will be negative 1. So that becomes to negative 1 times x over 1 minus x squared. And that will give us 1 minus x plus x over 1 minus x squared. And by simplifying further, we will have 1 over 1 minus x squared. So now we know that dy dx is equal to 1 over 1 minus x squared. And okay, now let the slope, let's use m to indicate the slope. M is equal to dy dx, and we're looking for the slope on right here, 1 over 2 and 1. Okay, so at 1 over 2 and 1. So dy dx is equal to 1 over 1 minus, instead of writing x, we write 1 over 2, because that's what x coordinate is. Okay, and yeah, so by simplifying that, we will have 1 over 2 to the exponent of 2. Okay, and that's gonna be 1 over 1 over 4, and it's gonna be 4. Okay, so now we can write the conclusion for the slope. So therefore, the slope of the tangent line to the curve y is equal to x over 1 minus x at the point 1 over 2, 1 is 4. Okay, so that's the first part of this question. And now we need to find the equation of the tangent line. Okay, so the formula should be y minus y1 is equal to m times x minus x1. Okay, and noted that we're given the point x1, y1 is just 1 over 2 and 1, and m is 4. That's what we have from previous step. So now we just substitute those into our formula. So we have y minus 1 is equal to 4 times x minus 1 over 2. And by simplifying that, we have y minus 1 is equal to 4x minus 4 times 1 over 2. So we have y minus 1 is equal to 4x minus 2. And we will have y is equal to 4x minus 2 plus 1. So y is equal to 4x minus 1. Okay? And now we can write the conclusion. So the equation of the tangent line is y is equal to 4x minus 1. Okay? Yep, so that's what we have for this question. So let's just go over again what we need to do in order to solve this type of question. So first, we need to find the dy dx, and we're just solving for the derivative for the equation of the curve, and we might need to apply, in our case, we apply the quotient rule. And remember, when you apply the quotient rule for the denominator part, don't forget the exponent, which is 2. Okay, and for the top, it's just derivative of numerator times denominator minus the derivative of denominator times numerator. Okay, and after solving that out, you need to apply that, substitute the specific coordinate into the equation to get the slope. And yeah, so after finding the slope, if we are asked to find the equation of the tangent line, we just substitute everything in, like the slope and the coordinate. Yeah. Yeah, so that's what we have for this question. Let's leave a comment. Solution is correct. Okay, so for our next question, we are asked to find the integral cosine x squared dx. Okay. Okay. So there are actually two ways of solving this question. One's from the trigonometry identity, one's from integration by parts. So let's do the method one first. So note it. Cosine cosine x squared is equal to 1 plus cosine 2x over 2. Okay, so if we let I is equal to integral cosine x squared, we're actually solving the integral of 1 plus cosine 2x over 2 dx, because these two are exactly the same. Okay, so we can also rewrite this as 1 over 2 plus cosine 2x over 2, because you're sharing the same denominator. And bracket dx. Okay, and that will be also equal to integral 1 over 2 dx plus integral cosine 2x over 2 dx. Okay, and that will give us 1 over 2 x plus sine 2x over 4 plus c, where c is the constant. Okay, so that's how we solve this by using the trig identity. And now let's do method 2. Okay, so still we have I is equal to cosine x squared dx. And we now use integral by parts. So solve by integration by parts. Okay, so there's u is equal to cosine x, and the dv is equal to cosine x dx, and therefore du is equal to negative sine x dx, and v is equal to integral cosine x dx, which is equal to sine x. Okay, because recall the formula for integration by parts would be integration u dv is equal to uv minus v du, integral v du. Okay, so I will be equal to cosine x sine x minus integral sine x times negative sine x dx. And for here, the cosine x will be our u, which is from what we have above, and sine x will be our v, which is from right here. And so integral sine x, yep, so that's the v again, and that's our du. Okay, so we pretty much just substitute everything into the formula, and that's what we have. Yeah, and so that's what we have. Okay, so yeah, so simplifying that, we have cosine x sine x plus integral sine x squared dx. And now we need to apply another trig identity. So noted 1 minus cosine x squared is equal to sine x squared, and that will be equal to cosine 1 minus cosine x squared, cosine x sine x plus integral 1 minus cosine x dx. Okay, and that will be equal to cosine x sine x plus integral dx minus integral cosine squared dx, and that will be equal to cosine x sine x plus integral dx minus I. Okay, so we move I to our left hand side. We have 2I is equal to cosine x sine x plus integral dx. So 2I will be equal to cosine equal to sine 2x over 2 plus x plus c. Okay, and we times 1 over 2 for both left hand side and right hand side. We have I is equal to sine 2x over 4 plus x over 2 plus c. Okay, and yeah, so now we have our final answer. And as you can see, both we are getting you the correct answer, one from the trig identity, one from the integration by parts. Either way works. So yeah, you can always choose the one you like. So let's leave a comment. She is correct. Okay. So our next question is saying that the pictured triangles are congruent. What reasons can be given? Okay. So the two triangles look like this. Oops. Okay. Okay. So as we can see, there's a congruency symbol for each pair of the corresponding sides of the triangles. Okay, so that's the first thing we notice. Let's write it down here. There is symbol for each pair of corresponding sides of the triangles. Okay, and the postulate that states that if the three pairs of sides of two triangles are all congruent, then it is the SSS postulate. Okay, so if these three pair of sides of two triangles are all congruent, is the SSS postulate. Okay, so as you can see here, so the yellow side is corresponding to the yellow side. The yellow side from the first triangle is corresponding to the yellow side of the second triangle, and the green side is corresponding to the green side of the second triangle, and the blue side of the first triangle is corresponding to the blue side of the second triangle. Okay, and so to write our conclusion. So therefore, SSS postulate is used. The correct answer is option A. Okay. Yep. So I think that's all we have for this question. Yeah. So just remember, if you're not given anything about the angle, they're telling you that there's congruency symbol for each pair of corresponding sides of the triangles, then according to the SSS postulate, these two triangles are congruent. Okay, so let's leave a comment. Solution is correct. Well done. So I think those are all the questions for today. And if you enjoyed today's Q&A and would like to be notified after we do this next, please hit the subscribe button and notification bell below. If you would like to submit your own questions, please read the link in the description. Remember to leave a like and a comment and share this video with your friend. And this has been Andrew from OneClass. I hope to see you soon.